Okay, so today we're going to do something that you guys have already done. It's not a huge jump, but it's how it's a little bit more involved because you'll need to definitely use cross multiplication, probably so here in this scenario. And there's a few more x's. Like not only is there one x that we're solving for, but there's two unknown sides with an x, like x plus 2 and x minus 3. So when you've got something like that, that's when it's important to know how to do this. So I'm going to do one for you, set it up, and then I'll let you guys do the rest. So let's see, go back to this. Okay, so here's an example. Okay, so we've got these two triangles, right? They're similar, and we're trying to figure out what x is. Again, basically, if we figure out the side, we can figure out the x. Well, we know how to do that, right? So we can do maybe this 18 right here, right? So let's do it into the big side, the small side. So we can do it like that, right? Big over small. We've done that before. So 18 over the 6 AC is the last two, so DC. So that would be 6. Okay, nothing to that, right? And then over here, we've got the big side here is x plus 8 over x minus 3. Okay, normally what we did before, right, is we would go 18 divided by 6, right? And then we would, we go 18 divided by 6, and then we would have 3, and then we would probably either multiply the bottom here by 3 to get the top, or take this and divide by 3 to get the bottom. So that should be very familiar at this point. The problem is neither one of these is a number. So, it's one thing if we have 5 on the bottom, 5 times 3 is 15. That's easy. But what happens when you have an x term with something else on the top and the bottom? That's when you're probably going to need to use cross multiplication. So if you remember, cross multiplication is multiplying the top thing of one fraction times the bottom or denominator of the other, multiply. So then you get, and then you multiply the bottom or the denominator times the numerator of the other fraction. Okay, so let me put that in black so it's not too crazy. Then by doing that, we're going to get 18. Now it's important, to, especially when you have two terms like x minus 3, to put it in parentheses like that. It's just good form. And that equals the 6 over here times x plus 8. At that point, this should be kind of a standard algebra problem for you. You distribute the 18, right? 18 times x, you got to distribute it times a negative 3 minus 54 equals 6 times x is 6x, 6 times 8 plus 48. And then you go through the regular steps. Get all the x's on one side, subtract the smaller amount, 12x minus 54 equals 48. Then we get all the constants on one side. So what is that? That's 90 plus 12, so it should be 102. Then divide both sides by, oops, my bad. I already know the answer, don't I? By 12. And what do you get? You get x is equal to, okay, x is equal to, I got 8.5. Okay, so, that's a decimal, but that's okay. I tried to make it a whole number, but it looks like this is decimal. But you know what? Let's just say I'm suspicious because I was looking for a whole number. Always remember, you should be able to plug this back in up here into the x. So 8.5 plus 8 would equal what? That's 16.5. And then 8.5 minus 3 should be 5.5. And since we already know that 18 divided by the 6 is 3, we should have the same factor here. So if I take my calculator and go 16.5 divided by 5, I get 3. Okay, so this does work out where I get 3 if I take 16.5. So it's okay. Even though it's a weird decimal that we're not used to, that still works. Okay? Basically, that's all you have to do on these problems here. The process is similar in terms of finding out, what a missing side is of a triangle if we know that the triangles are similar. So I'll let you guys do the next 4 problems to work out because I can tell you right now there's going to be a problem like this on a test that I want you guys to be ready for. There's one other thing that we haven't done that I want you to go over as well. So let me show you that. Okay, so the next thing we're going to do is we're going to look on page, it says 15 down here, but in the book it's actually page 14. Okay, so we're going to be on page 14. And we're going to talk about how you can prove that two figures are similar. And the answer is you can do it when you can map one onto the other using a series of transformations. Okay, so let's do one together. We'll forget this. We already know how these are here. We know how to figure out the value of x. We just did that. But let's go ahead and we also know how to tell if they're not similar by taking the ratios. So in other words, the big over the big, 14 over 10's got to have a ratio, and then the medium, 12 over 9, and then 10 over 6. All those have to have the same factor, scale factor, when we divide them. But what happens if we get two similar figures? What would the transformations be that would prove they're similar? Well, they'd be similar if we can map it on top and it would overlap it directly. Now, if I take this one, I move it over here, clearly it's not going to be. For one thing, the pointy sides are facing up. Here, the pointy sides are facing down. What could we do using transformations to show that they are similar or not? Well, one thing is, my first thought would be, I'm going to take this and reflect it so that at least, or I could take this one and reflect it. But let me just start with this one. I'm going to reflect it over the blue line. Let's pretend, I don't know why they don't have the X and Y axis. Let's just say it's the X axis, okay? So if I reflect it, what's going to happen? Every point up here over the X axis would jump down to right here, right? And then this point down three would go like that. This would go down 3 over here. These would stay right there because they're right on the X axis, right? So I'd have something that looked like, so like that, that, that. Okay, so that's the same figure. So now at least it's pointing in the same direction. Now the general shape is the long part of it is over here on the right side, so it's the long part. So I'm thinking it probably is, but I also have to make sure, I hope I moved, oh, perfect. Now also, so then that would be a reflection over the x-axis. But then I got to move it this way, right? So when I move it this way, how many? 1, 2, 3, 4, 5, 6, 7, 8 to the left. 1, 2, 3, 4. So we already know. So first it's a reflection. X-axis. Okay. And then it moved over 8 right, and then 4 up. So that's a translation. To both translation. Well, it's not done yet. You can tell this is bigger. Well, how much bigger? Well, let's check it out. Let's see if they're bigger the same way. So this is 1, 2, 3, whereas the big one is 4, 5, 6, 7, 8, 9. So I'm thinking maybe, is it 9? Well, let me check this one out. This one goes down 3 and over 1, whereas the big one right here goes down 1, 2, 3, 4, 5, 6, 7, 7.5. Oh, wait, guys, 7.5. Oh, wait, 8, 9. I got to go to the edge of this. My bad. So this goes down 9 over 3, which is 3 times more. So yeah, this basically is you would then dilate by factor of 3. Okay, let me see if I can get my pen to work here. Draw touch. There we go. Okay. It's not working there. Okay, so anyway, so from here to here, from the small one, it goes over 1, 2, 3. So if we did that, we'd have to start from here, from this point, which is 8, 4. And we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would work out. It would expand out to there. And then this, instead of going down 3 and over 1, times 3 would go over down 9, 2, 3, 4, 9 and over 3, 2, 3. So that one matches up with this point over here. Okay. And then this point, instead of going from this point, going down 3 and over 1, should go down 9 and over 3, 1. So if it does, it's 9 over 3. So that matches up to that point. And then this one, instead of going like it's right here, right? So I'm going to map it from 1 over, 2 down, should go over 3 over, 6 down. 1, 2, 3, 1, 2, 3, 4, 5, 6. So if we dilate this inside figure here, and I've made a lot of markings on it, 3 times, every point 3 times from the starting point. Again, point of starting, the dilation point is 8,4, okay? Then at that point, it would map onto it. Okay, so that's pretty complicated, right? But that's the way it works. Now, your assignment for today based upon that is to look at the next page. Okay, so the next page is going to be, I guess, page 16. I guess in the booklet, it's page 15, my bad. Okay, so you're going to think about whether or not you can find a step of transformations, whether it be rotations, translations, reflections, and specifically what would do it so that this thing right here would overlap onto that. Now, you know, they're different sizes. I think all of them are, right? So you'd have to think about if it's going to expand or decrease it. Now, do it from this figure right here, the ABC one. Well, I guess I did it from this figure right here. So you may want to think, what would I do to get from there? But you can also do it from this figure here and do it for all 4 of these. And when you're done, come check with me and I'll go over it with you. But then there's also one other thing on the assignment that I want you guys to be aware of and be able to do as well. And that is on the back side of this assignment. And you're going to get one of these figures. And ideally, you figure out what would work here. And then you're going to go through, because on the exam, we're going to get something like this. We're going to get a figure. It's going to 2 figures. And you're going to get statements about how one would be mapped onto the other. How could we get X, Y, Z, what moves, transformations could take this thing and map it onto that, and you're going to get some true and false questions. For example, would you move X, Y, Z up or down? And would you reflect it? And if so, which axis? Would you make it bigger? Would you dilate it? If so, what scale factor? So it's going to talk about those things. So you're going to need a question like this on the exam where you're going to put true, false based upon what's happened. You just got to keep it really carefully and think about what would happen if those kind of transformations happened. So when you're done, check that with me and I'll go over it with you.